Finally, let's discuss the administrative tasks associated with the network. In most cases, after installing the system, you have a more or less configured network in accordance with the DHCP settings of your local network. The most you need is to set up a password for your Wi-Fi. But in some cases, it would be helpful to have some utilities to view and manage network settings. Unlike other devices, network interfaces don't have their own representations in the device files in the dev directory. You can work with them only with the help of special utilities. Traditional set of utilities for network configuration: ifconfig to configure a network interface, and route, which show and manipulate with IP routing table. With no arguments, ifconfig just shows us the current state of enabled network interfaces. By pointing to a network interface, we can up and down them. We can also manually set the IP address and net mask for such interface. We can use the route utility to work with the routing table. To view the route table, we may run command option and shows numerical addresses instead of trying to determine symbolic host names. That can be useful if you have problems accessing the DNS server. With this command, we can add and remove routes to hosts and networks. We can set gateways to them. In modern Linux distributions, those net tools are outdated and are not installed by default. They are migrating to more versatile IP utility, which also supports more advanced networking options than net tools. You can use IP link to perform the same tasks as ifconfig. And IP route to replace route. The next important task when setting up your network is setting up DNS resolving. The configuration is placed in etc resolve conf. Here we can configure name servers up to 3 name servers. Also, using the search configuration option, we can configure the domains in which short names will be searched. And finally, a few words about regulating network access to your computer. As we understand, network attacks are currently the most dangerous. The most famous tool for restricting access is a firewall. At its deep level, the firewall in Linux is controlled by the iptables utility, and moving to nftables now, but at a higher level, different systems manage it in different distributions. Canonical's uncomplicated firewall to configure the iptables on every Ubuntu and Debian system. The firewall isn't enabled by default in Ubuntu, nor installed by default in Debian. As its name suggests, it's fairly uncomplicated to set up and maintain. It has an easy to remember syntax that's more friendly to human users than the underlying iptables rules. Fedora and Red Hat Enterprise, like Linux's, enables firewall daemon by default. It's a firewall CMD front end. Has almost the same feature set for basic firewall management as UFW and adds network zone management to the mix. Zone management allows you to set up presets which with rules for different network conditions, locations, for example, home and office, where all communications with local machines are allowed, and public Wi-Fi where no communication with the same subnet would be allowed. Rules can be applied automatically per network interface or used through Network Manager and the GNOME network graphical user interface system config firewall. Both front ends come with predefined rules for common server services and protocols. Those rules include a keyword name and associated industry standard and default ports for running services publicly. They each come in their own formats that aren't interoperable with each other, of course. UFW use service-named files containing one line with the port and protocol, and firewall D uses 6 lines of XML to create the same profile. The best policy is to simply close all services from the internet that you do not need on your computer, and only open those that you need for remote access, for example SSH, and then just use the lighter tweak tool, host access control files. This is the configuration for the so-called TCP wrapper, which was originally developed as a TCP/D service for the INetD superserver. And now its functionality is included in the librapp library that is used by several network services such as NFS. Again, the easiest way is to disable everything in the configuration file etc hosts deny and allow only a fixed list of hosts to access your computer, for example, via SSH, and hosts allow. Using this mechanism is easier than using a firewall because all changes are made immediately after saving the configuration file. You don't need to reconfigure and reload any services. If we talk about older classical systems, then TCP wrapper, TCP/D, is configured through the INetD service. As well, see, this is a so-called superserver designed to make the life of network developers easier. To create the server side of a network application, you just need to develop an application that reads std in and writes to std out. And write the service configuration to the INetD configuration file. All the work of listening of network sockets and maintaining the connection makes a super server for you. Classic services such as FTP, mailing POP3 and Telnet were designed to work with INetD. It is also possible to configure an HTTP server for access via INetD. Newer systems have replaced INetD with XINetD, which provides better protection against the DOS attacks, and replaced with the systemd in newest systems.